Hello and welcome back to Fullerton College's pre-press class. This is Professor Ben Hewitt. We are taking a look at PIA's pre-press trainee handbook, task 4, module 3, digital image basics. We're going to take a look at the different things that are the building blocks of digital images and the basic concepts necessary to understand what's going on inside that magic box on your desk that makes the pretty pictures show up on your screen. So we're going to talk about color channels. We looked a little bit about this in the past. We were talking about our red, green, and blue primaries and how they appear in Photoshop. We'll look more in depth here. We're talking about image color modes, things like grayscale, duotone, tritone, quadtone. I swear those are not a cappella groups. RGB, CMYK indexed, and CIE lab or CLab. And we're going to look at reproduction problems resulting from wrong or incorrect, improper, inappropriate use of resolution, which is a big issue. Okay, let's start with a very basic here. Although, don't be ashamed if you haven't heard this before. It's just because you haven't heard it yet. So allow me to tell you. If you have heard it, listen in because you might hear something new. Anyways, so a pixel, first off, they don't have the actual definition of here. The word pixel itself is an abbreviation of picture element, pixel. So these picture elements, these pixels, are individual dots, although they are square dots on your computer screen. And each one contains its own color value. How complex and what color? Well, that depends on exactly how much memory you're assigning for the computer to remember that information. We will talk more about that as we go through. But overall, each one of those little squares can have its own color and its own value based off the color mode it's in and how much memory you've assigned, and they all butt up next to each other in a square grid. It's like a mosaic. It's a big set of tiles, and each tile can have its own color. And when these tiles are next to each other, to you, a human viewer, it starts to look like an image. Although to the computer, it's still just a spreadsheet of numbers. And the amount of memory assigned to it determines how many numbers and how complex a math it can use to define each cell. If you remember our video from our stand-up math band, Matt Parker there, you've seen how a computer screen handles color. And each one of those triplets of 3 cells makes up 1 pixel. So here's some important aspects of image files. There is color space, there is resolution, and there is file format. Here's 3 types of images, all using pixels, stacked in a neat little pile there on the right. Line art, or line work as it's called, is the pure black and white image on the top right, where there are black pixels and there are white pixels. This takes the least amount of memory per pixel, and each pixel can either be black or white. We'll talk about this more in detail. The middle image is a grayscale image, where the entire, or each cell, or each, pixel in the image has the ability to be one of 256 shades of gray, including all the way black and all the way white, and 254 other steps in between. And the bottom one is a color image using the similar thing, but more memory to define multiple channels. We will get into this later, but you know how I'm so excited to get ahead of myself and talk about the concepts that are really interesting to me. Did you know that an RGB color image is essentially 3 grayscale images on top of each other? It's true. Let's go back and talk about black and white images. So there's 2 types of images that contain no color and just tonal differences between light and dark. There's line art, which is really pure black and pure white and nothing in between. And there's grayscale, which is all those different levels of gray available. Both these modes only do with one channel, and the channel is called gray, and both of them only render one color at a time. And you're probably saying to yourself, yeah, gray, that's the color, right? Allow me to say, no, not necessarily. As you may have learned so far, hopefully, and I think we've talked about so far in our class, any image carrier in printing, whether we're talking a printing plate from a rotogravure system used to print high-end magazines and US currency, to an inkjet printer, to a silk screen used to print t-shirts, all of it is capable of doing only one thing, and that is controlling where ink goes. It only answers a yes or no question, depending on the resolution of the image carrier, given any given spot on its page. Is there ink here? Yes or no? Black and white images do the same thing. And if a black and white image is used with a different color ink, it is going to use that color ink as every step along the way. So a black and white image, remember, if you've ever done screen printing in person, I know it's been a little while since we've done that on campus now, but that means that you're able to produce a screen that can print any color of ink using a black starter image. Line art is also called bitmap. There's actually an old file format from Microsoft called .bmp for .bitmap, and that was an early image file type. And those are not necessarily black and white, but a bitmap, if you're using Photoshop and you convert to bitmap, that means you're creating single bit images. If you remember the basics of computing and what a bit is, let's go back for those who weren't here with us in the previous semester on that one. A bit is a single digital light switch. A bit is the smallest amount of computer memory you can have. And a bit is a single number that is either going to be a 1 or a 0, on or off. That's all it can do, either yes or no, on or off, 1 or 0. So a bit map is a grid of bits, and each pixel in the grid is a light switch of on or off. When it's on, if you're talking in a additive color model, on means white, off means black. If you're talking a subtractive print model, on means black, where there is ink, and off means white or paper, where there is no ink. But either way, it is either going to be, yes, there is color here, or no, there is not. So the Photoshop bitmap cannot do shades of gray. It can only do on or off. Again, it's a bitmap. Bits are only one individual piece of computer information. So 1 pixel equals 1 bit, yet again. That's why you can't do shades of gray in a bitmap, because with a bit, you're only able to have 2 values, black or white. That's all it can do, on or off. Here's a good picture of line art in Photoshop. And let me tell you, I get all sorts of nostalgic goosebumps looking at this, because when I was a small kid, the computers I grew up using all had images that looked like this. In fact, a lot of the computer games I played, even if inside the game would be like a simple little wireframe or whatever it would be, they would have this splash screen when it's first turning on. The loading screen would have a high quality image that looks kind of like this, made out of dots. So when you want to have a gray tone, you have equal amounts of black and white dots next to each other. When you want to have a darker gray, you have more black dots and fewer white dots. And when you want a lighter gray, you have more white dots and fewer black dots. It takes you back to the 80s. Moving on. So now you can also have a pixel in a color channel and not only in a bitmap. So a pixel can be the smallest tonal element in a digital image, and you can individually assign colors to each pixel. So when you're assigning more than a single bit per pixel, then you're able to have not just that one on or off, you can have a maximum density, which is the darkest color, a maximum brightness, which is the brightest possible color, or a shade in between. How many shades? Well, I'm glad you asked. That depends on how much memory you're giving it. The more memory your computer assigns per pixel, the slower your image will load on your monitor, and the more in-depth, minute control you'll have over individual subtle color differences within it. By combining various shades of primary pixels, you can make millions of colors, even billions sometimes. The primary colors are stored in color channels. Let's talk about channels. But first, let's talk about color spaces. So pixel images, if you're using these things, you're able to use stuff called grayscale. You can also have duotone, tritone, and quadtone, which right now is not a very popular option in printing, but it was when I was a kid because full color printing was less common. We'll talk about that when we get to it. RGB, you know, you love it. It's additive color model and it's monitor color. It's what your computer wants to see and show you. CMYK, cyan, magenta, yellow, black. is your subtractive color model, and that is your typical printer color. There's also something called indexed color, which is another one of those trips down memory lane for me, because that was how computers showed you color in the early 90s. And lastly, there's something called lab color, which is really interesting, and we will talk about that probably in more detail than you want, because it fascinates me. Therefore, I will talk to no end about it. So, grayscale. We'll start with this, because honestly, the grayscale is a intermediate-sized building block that makes up color models. If you want to stretch this to some sort of like scientific analogy, a bit would be like an atom, individual atoms. Grayscale images, we start having more than a single bit per pixel, we're starting to talk about molecules. It's still a building block, but it's not the smallest possible building block. It's made up of smaller building blocks within it, depending on how many bits you put in there. Now, a grayscale image has a single channel, and the channel is called gray by default, but again, you could always use a grayscale image with any single color of ink if you wanted to, when you get to press, that is. So each pixel in a grayscale image can be black, white, or, depending on the amount of memory you've given it, a shade of gray between black and white. All printed black and white halftones begin as a grayscale image, and they are called 8-bit images. 8 bits means you have 8 on-off switches. There's a bee buzzing by my head here. Okay, sorry, we're back. So the 8 bits allows you 256 shades of gray. There are many reasons to scoff at the trashy romance novel series. Mine is different than most people's. 50 shades of gray? Only 50? Ooh, that's not very high performance. Base level, I'm getting 256 shades of gray, guys. Just saying. In Photoshop, a grayscale image looks like this. You should be warned, though, that it is possible on a computer, when you're using grayscale images, especially if you pulled them off the interwebs, there's a good chance that you're going to end up with a RGB grayscale image, which looks grayscale, but is in fact made up of 3 channels instead of the 1, which is called gray. You might need to take them to Photoshop and convert to the single color grayscale to use properly. Otherwise, you get some strange effects. Effects I won't talk about this minute, but we will talk about another time, because they are important and they've haunted me my whole career. Duotones, tritones, and quadtones. A duotone image also has 1 channel, but this is a way of cheating to get more depth out of an image than you would otherwise have gotten out of using a single channel. If your channel is called duotone, you choose 2 colors of ink to represent that tone. Often you'll use something like, you'll mostly use black, but also a second color like sepia. And by being able to mix the on and off amounts of both black and an intermediate color, you're able to have much more control over the levels of bright and dark steps you can get. By having 2 colors of ink, your darkest color is darker than the darkest you'll ever get using a single color. And that also means that you'll have more steps in between. So you can have a much more dynamic, in terms of image light to dark tonality, than you could possibly get using just a single channel of a single color. I'm going to pause here because I'm out of time, but we'll be back soon to talk more about duotones, tritones, and quadtones in the next video, which I'm going to call part 2.